Hi, my name is Tom. This is my second video, and this time we're covering a bit more of an advanced Niagara fireworks effect. We will be covering two different versions, one with streaks following the particles as well as the secondary explosion flickering out towards the end, and the other option being several spheres expanding and changing color according to a noise field. Let's start with a fountain preset and changing its velocity to something around 5000. Next, you want to lower the spawn rate to around 1 and set the gravity to -400. Adjusting the sprite size is only so that we can see them while working, as we will deactivate the sprite renderer later for this emitter. Increase the lifetime to 4 to 4.5 and add a generate death event in the particle update. For this to work, we need to go into the properties and enable the requires persistent IDs. Rename your emitter and make sure to set the bounce mode to fixed for it to work properly. Next, we're going to add a minimal emitter for our rocket trail. Start by adding a spawn particles from other emitter node. Clicking fix issue will add a solve forces and velocity node, in which we will need to click fix issue again. Go back into spawn from another emitter and select your rocket emitter. Set both the spawn rate and the spawn rate per particle cap to 2000. Follow by changing the lifetime to random and keeping the minimum and maximum values at 1 and 2. Make sure to set your sprite size to uniform. Next, I added a shape location with a cone as our primitive. This is so that close to the rocket, it looks like our particles are being shot out towards the back. For it to face in the right direction, adjust your cone length to -10 and change the cone angle to your liking. Now we want our particles to start small, get big and fade out towards the end. Do this by adding a scale sprite size node, changing the curve preset and adding a fourth key by right clicking and pressing on add key or pressing your middle mouse button and adjusting the values as shown. Now add a curl noise force in the particle update and change the noise strength to a float from curve modifier. Change your scale to a random range float and add 500 as a minimum and 1000 as a maximum. For the noise frequency, we want a float from curve again. Change the preset to the same as in our scale sprite size and move the middle key a bit to the left. Also increase the value of your scale curve. Now the only thing that's left for it to be looking like a rocket trail is the color. Start by adding a scale color node in the particle update and change it to RGBA linear color curve. Start with a bright yellow, fading into an orange, into a red, dark red and a gray at the end. Also make sure to direct set your color in the initialize particle. Feel free to adjust the color to your liking and move the sliders to the position you prefer. Also make sure you turn off the sprite renderer from our rocket emitter as we no longer need it. It only acts as a location transmitter for the trail. For the explosion, we're going to be using the same technique I showcased in my previous tutorial that will give us the location of the death events of our rocket emitters and allow us to define the time in between the fade out of the rocket and the explosion. Create a minimal emitter, add an event handler and a received death event in it. Set the source to your rocket emitter, the execution mode to spawn particles and the spawn rate to 1. Change the lifetime mode to random and set a minimum and maximum value. This is the time it will take from the fade out until the explosion happening. Once again, turn off the sprite renderer because this will only be running in the background. Add a generate death event in the particle update and click on fix issue. Now click the checkmark at persistent IDs and make sure it's set to fixed bounce. For the explosion, we're going to be starting with a minimal emitter again, add an event handler and a received death event once again. Inside the event handler properties, select the death event of our location emitter, set the execution mode to spawn particles and set the spawn number to 500, not the max events per frame as shown in the video. Now we want to set a position parameter inside of a set parameters node. Name it the death event location and it's going to be defined by our stack context position. This is going to save the location inside of a variable we can use later on. Follow by adding a shape location and a add velocity node. change the velocity mode from point, and here we're going to use the previously created parameter for the origin. Change the velocity to 3000. For it to work, we need a solve forces and velocity node in the particles update. Next, we add some drag and some gravity and adjust the z value to -200. Next, change your lifetime mode to random and set a minimum of 3 and a maximum of 3.5. Here you can also already set your color. Set your sprite size to uniform and enter a value of 40. For the fade out, we want a scale color. Turn the alpha into a float from curve and choose this preset. We also want a scale sprite size, in which we can just do the same. Now we only need to generate a location event and turn the requires persistent IDs to true. For the secondary explosion, we can just duplicate our emitter, and as always, don't forget to name your emitters accordingly. Start by decreasing the velocity from 3 to 2.5k. Next, you want to add a float from curve into your drag value and change the scale to 2. Once again, you can adjust the color to your liking. The next step is to delete the generate location event and generate a death event. Being done with the small explosion, we now want to create the trail for our big explosion. Start by adding a minimal emitter and changing the renderer from sprite to ribbon. Create an event handler and receive the location event from our big explosion. Set the execution mode to spawned and not to every particle as shown in the video. Set the spawn number to 1 and inside the receive location event change the color mode to apply. Now set the ribbon width in initialize particle to the same size your explosion particles have. Change the lifetime mode to random and set the minimum to 0.4 and the maximum to 0.6. I went back to my big explosion and decreased the spawn number to 200. Now we want to scale our ribbon width towards the end, and we do this once again with a float from curve. I went with the smoother preset and slightly adjusted the tangent of the last keyframe. Now the only thing that's left for this effect is the flickering of the second explosion towards the end. For this, start with another minimal emitter, with another event handler that receives our death event from the secondary explosion, aka the small explosion. Set the execution mode to spawn particle and the spawn number to 1. Add some gravity and click fix issue to add a solve forces and velocity node. Adjust the Z value to -50. Add a scale color and set it to RGBA linear color curve. Inside the alpha, we're going to add a couple of keys by double clicking and letting them alternate between values of 1 and 0. You can always adjust the flickering speed by adding more or less keyframes. We also want our particles to gradually get smaller over time, and we can do this through a scale sprite size. For the color, you can just copy-paste the code from the small explosion into your flickering color and make sure to adjust the value as well. In the end, I went back to my small explosion to change the sprite size mode from uniform to random uniform, and I did the same on my flickering emitter. Make sure both of these emitters have the same values. We now finished the first fireworks effect and will now continue with the second one. For this, we will duplicate our previously created effect, rename it, and inside of it, delete the small explosion as well as the explosion trail. Inside of your shape location, change the distribution to uniform and double your spawn number inside of the event handler properties. Next, we want to add a curl noise force as well as a color node. Inside of it, we want to add a lerp linear color modifier, in which we will change the lerp factor to a clamp float. The float we will then change to a multiply float, and for the b value we will need a make float from vector. Inside of the parameters window at the bottom left, you can search for physics force, take the transient one and pull it into the vector. Set some temporary colors and make sure to move your color node in front of the solve forces and velocity one and the scale color even further up the tree. Now you should see your particles changing color in rapid succession. To control this, we will go into the curl noise force and change the noise strength to a float from curve, choose this preset and adjust our scale curve to 50. For the noise frequency, we want a float from curve as well, just with an increasing linear ramp and a value of 0.3. You can see the colors are now changing slowly as the particles are moving through the noise field. We will now create some custom user parameters through which we will be able to change the colors of this effect as well as the rate at which the particles are changing their color. Create a float parameter and pull it into the scale curve of the noise frequency and create two linear color ones and pull them into the temporary colors we created earlier inside of the color node. You can now easily change the color of your effect through these parameters. You are also able to access these through blueprints like covered in my last video. To create the next part of the explosion, duplicate your emitter and change the drag value to a float from curve with a value of 1.5. Also, decrease the velocity from 3000 to 2.5. Don't forget to name your emitters and then repeat the same process. Adjust the drag value from 1.5 to 2 and decrease the velocity to 2000. Get rid of the flickering emitter and duplicate the first big explosion and rename it to your outer explosion. In its drag value, we want it to be slightly lower than the original one and decrease the spawn number to something like 50. We also want our spheres to be fading out from the inside, and we can achieve this effect by having lower lifetimes on each sphere, highest one on the outside, lowest one on the inside. Thank you very much for watching this video. I hope you learned something, and let me know if you liked this different approach from the previous tutorial, a more voiced over approach instead of the me doing it live and you going along. I'm always happy to receive feedback, and if you have any questions, let me know in the comments. I will be looking forward to answering them, and have a nice day.